I'm Anil Kumar sharing with you different ways of solving polynomial functions. In this particular example, we'll write the equation of a polynomial function from given set of points, and we will use finite difference to figure out what is the degree of the polynomial. Then we'll write general equation and solve for it. Here is a simple question for you. You can actually copy the question, pause the video, solve, and then look into my suggestions. The question is, determine equation of a polynomial with following points on its graph. Points are 1, 2, 2, 0, 3, 0, 4, 8, 5, 30. I'll also advise you to use one of the techniques which I've taught to simplify and then solve. Okay, so let's begin with standard method of finding finite difference, right? So we'll find finite differences and then see whether what degree this function is really. Okay, so finite difference means y2 minus y1, 0 minus 2 is minus 2, 0 minus 0 is 0, 8 minus 0 is 8. You will notice that I have taken very simple values to work with, and I also keep calculator handy. So we'll use calculator. Okay, 30 minus 8, because these questions could involve a lot of calculations, right? 22. Now we'll do the second difference, and which is 0 minus 2 is 2, 8 minus 0 is 8, and 22 minus 8. Let me do 22 minus 8 using calculator, which is 14, right? Now let's continue this 8 and 6, and let's do 14 minus 8, which should be 6. Okay, that's perfect. So what you really get is third finite difference as constant. So the first is not constant, not linear. Second is not constant, not quadratic, but the third is constant. That means it is cubic. Perfect. So we get our result, cubic. If it is cubic, then you expect the equation to be in the form of f of x equals to ax cubed plus bx squared plus cx plus d, right? That is the form which has four unknowns, the coefficients a, b, c, and the constant d. That really means that you will write four equations, right? So let me show you the old way, it's not standard way. Then you say 1, plug in 1 here, so 1 you get a plus b plus c plus d equals to 2, right? Second equation will be using 2 and 0. 2 for x, so 2 cube is 8, you get 8 plus 2 square means 4b plus 2c plus d equals to 0. Then we write the third equation, right? Third equation is 0. Okay, 3 cube is 27. Okay, 27a plus 9b plus 3c plus d equals to 3 is also 0. Perfect. And then the fourth equation, 4 cube is 64. Okay, 64. A plus 4 square is 16b plus 4c plus d equals to 8. Now you have four equations to solve. Solving equations 4 simultaneously is not an easy job. There are possibilities of mistakes and getting wrong answer, plus it takes around 10 minutes to solve such a question. Okay. Now you could do that, but here is a technique which we are practicing, and I am calling that as my alternate method, right? So you could use some of these techniques to solve your question. It is not necessary that all the things will fall at one place, but sometimes we can apply some learnings. One of the things which you've learned so far is how to find the leading coefficient. So that is the leading coefficient. How to find a. As you know, a is equals to finite difference, whatever you get constant. Let us say we get nth finite difference, divided by n factorial. This is what a is. Now in this case, third finite difference is constant, so we can say for us a is equals to third finite difference, which is 6, right? Since it is third, so 3 factorial. 3 factorial means 3 times 2 times 1, so that is 6 divided by 6, we get 1. So from this finite difference, we actually get the value of leading coefficient, right? So remember the relation between, so that is a relation between finite difference and leading coefficient. Perfect. So I'm also providing you with some links which will help you to review these concepts, right? So first step is we have found the finite difference and the leading coefficient relation, and that helped us to guess the value of A. Since we know A, now we need only three B, C, and D to be found, so we need only three equations. So we can cut down solution to solving that part of the matrix. Do you see that? So instead of all this, now we will remain to this. That should not take more time, right? So that will nearly take half of the time than this big matrix, correct? So we have already reduced, and this could be done for any polynomial equation. Remember that, okay? So first step. Second, what you should do is look for zeros. So now analyze zeros. Here we see there are two zeros, right? And the equation is cubic. So that means that I could write my function f of x as equals to a times x minus x1, the first zero, x minus x2, the second zero, x minus x3, the third zero. Maximum we could have three zeros for a degree 3 polynomial. There we go. So instead of starting with standard form, we could actually start with factored form, right? So what I'm trying to say here is you have an option. You could start with factored form, right? Use factor form of the equation and get your answer. Now in this case, we could see very easily a is 1, so we'll write 1. I'm writing, but you don't have to write. X minus x1, first 0 is at 2, good job. Second one is at 3. Okay, third one we don't know. We'll try to figure it out, right? Third one we don't know, so we'll write x3, right? I'll also show you a technique how to find third one from here, right? So we'll take it up later anyway. But this is even simpler, right? One unknown, it means what? It means that just one point is required. We already know two zeros. So now at this stage, we could actually use 1 point and solve for the equation. So what we get here is we could use f of 1. And in that case, we know this is 1 times x minus 2 times x minus 3. And replacing x with 1, 1 minus x3. And that is equal to 2. 2, right? So this is a very simple equation. Now the job is to find x3, right? So simple. Do you see how we have just reduced this question from solving 4 different equations to 3 to just 1? Do you see that? So that is 25% of the time, right? Of the whole time, less than that. And also it ensures correct answer. So let me see how to solve this, right? I should have written 1 here for both x values. So I'm rewriting this equation. So what we have here, actually I should have written 1 here. So I'm writing here again, f of 1 is 1 minus 2, 1 minus 2, 1 minus 3, 1 minus 3, and 1 minus x3, right? 1 minus x3. And that is equals to 2. Now 1 minus 2 is minus 1, and 1 minus 3 is minus 2. So minus 1 times minus 2 times 1 minus x3 is equals to 2, right? 1 equals to 2. And that is to say that 1 minus x3 should be equals to 2 divided by, product of these is 2, right? So it is also equals to 1. And from here we can solve and say x3 is indeed equals to 0, right? So when you solve, you get x3 as 0. Since x3 is 0 for you, you could write down the equation, right? So now you get your final answer. Let me write in a different ink altogether. So we'll substitute x3 as 0 here. So we get our function f of x as equals to x minus 2 times x minus 3 times x minus 0 is just x. Do you see that? So that is your answer. So that is how you could very easily get the solution of such a question, right? So that is the way you could do it, right? Now I can also show you a technique of finding that 0 from the data. We could do reverse calculations, right? That is to say, we were trying to find when x is 0, what is the value of y? That is the y-intercept. We'll talk about it, but what you could do is you can trace it backwards, right? What I'm trying to say is, if I want to find this value, then I know that the difference with this number should be 6. That is a constant difference. To get 6, what should be here? So if you trace it backwards, you will get the one more point at 0, and that will also help you to solve the question. We'll explore this technique in the next video, and then you will see how easily we could actually solve polynomial equations even if they are very difficult. Okay, so I hope you're enjoying this process and learning. I'm Anil Kumar. You can subscribe and learn a lot. Thank you and all the best.